All right, so I'm going to talk a little bit today about serving IIIF. There are a couple ways that this is done in the community, and specifically, I'm going to talk about doing it in ways that are performant, which can be tricky. So let's talk about what is IIIF and what does it mean? So IIIF is the International Image Interoperability Framework, and it defines several programming interfaces for standardizing methods of describing and delivering mostly images over the web. I say mostly because it also has been expanded to cover quite a bit of AV at this point, and some presentation-based metadata such as structure and sequences for content. Um, and has also been expanded to include quite a bit of things like the ability to connect to transcripts or just written descriptions, timing information, etc. So a IIIF request, so a IIIF viewer asks typically for a IIIF request, and that's made up of two primary parts, a manifest and the assets. Um, the These things are paired with a viewer such as OpenSeaDragon, Mirador, or the Universal Viewer to display sort of those manifests and assets. So this is what a manifest looks like. You can see that it is essentially a JSON document. We learned about JSON a little bit from the core presentation yesterday. This is similarly a structured JSON that describes canvases and the things on those canvases, as well as metadata about the items on those canvases. Samvera applications, Hyrax, Haiku, and Avalara, all support both V2 and V3 of the manifests. But especially and I won't speak to Avalara because I haven't done performance tuning there, but in Hyrax and Haiku applications, this can be pretty slow. And there can be slow for a couple different reasons. So why are they so slow? Um, so the three things that we found in performance tuning that really have a big impact on IIIF serving speed and the feel of a page load are image cache busting, manifest generation, and then the asset serving method. So let's kind of break those down one at a time and talk about them. Um, the first one is sort of specific to the UV. The UV has by default on a feature that prevents thumbnails from being cached or images of any kind from being cached. So it sends notice to the server when it requests a thumbnail. It says, regenerate this thumbnail. Don't give me the cached version under any circumstances. So that means that every single thumbnail and every single image is, got a special header on it and a special param that tries to keep it from being cached, which is not great. This turns out to be really, really easy to turn off. You just tell it to stop doing that. So this thumbs cache invalidation flag being set to false, all of a sudden those thumbnails will come in really quickly because they can be cached at whatever caching level you might be using. You might be caching them. They can be cached in the browser. So if I've been to this page before, they'll stay cached. They can be cached at the web server level. We talked about a couple different ways you could cache yesterday in the bot blocking talk. So like this is a very simple thing. I don't know why this is on by default. I'm sure there's some historical reason, but we found that it makes a significant user impact because you get to see those thumbnails kind of right away. The second one is the manifests themselves. You're building these JSON documents. You're looking up records in order to do that. And in order to, and once the manifests are generated, they don't really change unless the documents themselves change. So you can turn on caching for manifests by flipping this flip-flop flag and in Hyrax or Haiku, and then those manifests will then be cached. This isn't on by default, and it isn't on by default because it only works if your works are public. And the reason for that fundamentally is we check the permissions of each item as we add it to the manifest. So if I cache the manifest and I cache the manifest as a user that's allowed to see all 5 items in a specific manifest, then you come along, you're only allowed to see 3 of those items. I have to regenerate that manifest because I have to check each item as I add it to the manifest to see whether you have permission for it or not. This is a solvable problem. We could make it so that the caches themselves have permissions on them. We can do partial caching and just assemble them at the last minute. There are things we could do to improve this, but at the moment it's only public things that are cached, which is why this is off by default. I do think we probably minimally should add logic that excludes any non-private items from ever being cached, and then we could turn this on for most uses. And the reality is in the wild, a large percentage of these works are public, and it's really the public ones that you're the most worried about the speed on because those are the ones that get access the most often. So there's the most value for caching them. All right. So that's the manifests and a little trick about thumbnails. Let's talk about serving the assets themselves. Serving the assets is like this is what actually sends the image, or streams the video or audio to the user's browser. And typically, there are a few ways in Hyrax applications that we see IIIF assets like distributed. And this, I think, is broadly true across Avalon. I know the folks at Northwestern use serverless IIIF. So this is true kind of in the broader Samvera context, but I'm going to talk very specifically about Hyrax and Haiku here for the rest of this presentation. So you can statically pre-generate the items. And because the IIIF server structure allows you to just ask for like arbitrary sizes of images, you won't be able to do that statically. I mean, I guess you could generate in 1 pixel increments all the different combinations for an image, but I don't think that that's a good idea. So fundamentally, like I think that you're realistically limited to being able to like you basically have to say, okay, if it's bigger than this and less than this, I'll serve the small size. If it's bigger than this and less than this, then I'll serve the medium size. If it's bigger than this and less than that, I'll serve the big size. And you have to break your images up into pieces, and this can take a ton of extra space, frankly. So this serves really, really fast, but requires a lot of pre-generation and can really explode the size on disk that you're storing all of these items. So there are specific cases where this is really useful, but realistically, it's not for everybody, and it certainly is a like custom thing every time you need it. Then there's Riiif. So our IIIF has been mounted in Hyrax as a default, as the default way we use IIIF for a really long time. I know a lot of folks get very frustrated with it and feel that it is very, very slow and struggles. But frankly, the people at Stanford use it in their blacklight applications very successfully. Other folks use it very successfully. This is another case where we are maybe making our lives harder than they have to be, and that making of our lives harder than they have to be is causing us some problems. So I'll tell you a little more about that. But this is a Rails engine. It fits in the same like code style as the rest of Hyrax. It's very similar in how you would deploy it. You can deploy it together with Hyrax or Haiku as an engine. In fact, it is deployed by default unless you specifically remove it. So even if you're using a different IIIF server, you probably are running the Riiif code in the background and just not utilizing it. Then there's Cantaloupe. Cantaloupe is one of a class of Java-based IIIF servers. There's 4 or 5 of them. Cantaloupe by far has the most features and the coolest logo, and therefore is the one that I think the most people know about. There's some slight feature differentiation between the other ones. We're not going to really talk about them. Again, cool logo, therefore they win. It has lots of features. It is a fairly hefty Java application, lots of customization. It has a ton of configurability around caching, how it reads and writes the files. You can use either the open source JPEG 2 2000 libraries, or the slightly faster closed source version if you buy a license for it. Um, Lots of opportunities and options here with Cantaloupe. Um, Also, I will say Rift does support Cockatoo, which is the fast JP2 generation. Um, so that is an option, but something to note. All right. Then there's serverless IIIF. Serverless IIIF is a Samvera project. It uses Amazon Lambdas in order to serve your IIIF. So it reads directly from an S3 bucket and only from an S3 bucket. It's the only thing it knows how to do, and serves them out without having to run a server all the time. This has a tendency to be very fast and very cheap, which is nice. It does have some technical limitations in the way that it is set up. There is an underlying node-based library that does the actual IIIF stuff here. So it would be theoretically possible to have an Azure Functions version of this or GCP version of this, or to have a standalone version of this that does these same things. But the fundamental power of it is the simplicity around you read from static files only. This is your only source of truth. There is no other place you can put this. We did rig up a version that read from Fedora at one point, and I will tell you, I did it only to prove the next slide. We can make them all slow. In fact, we can make them all ungainly slow and really frustrating to use. And the reason for that is the default configuration for both Riff and Cantaloupe in Hyrax applications says to read the files from Fedora 4. So what you do is you say, I want image X. Then it knows to look up image X it makes a call to the Hyrax application that looks up image X in Fedora. So it loads the whole document. And then it loads the file from that document. Then it streams that file over to the IIIF server, which does its processing on it and then streams it out to the user. And it is that process, the two Fedora lookups and the file transfer, that are the slow part. So you can make any one of these slow by doing the Fedora, by going through Fedora. This is not how we should be serving these assets. And by optimizing this, it makes a lot of the things that have made both Riff and Cantaloupe seem undesirable just go away. So what we can do instead, and I've done this in Riff briefly, in kind of a proof of concept, but I've done it in production for both Cantaloupe and for serverless IIIF, is if you're still using Fedora 4, you have your Fedora 4 assets go to an S3 bucket. They also go on disk. But either way, the SHAs of those files are stored in Solr. And so without ever doing a Fedora document lookup, you can access the files directly either from the file system or from S3, and therefore connect that to your IIIF server and serve them directly. Um, this works with the IIIF print gem. The configuration for this all exists there. You can also just extract that little tiny piece if you don't need the rest of IIIF's print feature set, and do an override in your Hyrax application. But this just I cannot describe what a speed boost this is. This makes the whole thing seem fast and solid, both with, again, with Cantaloupe in production serving very, very large documents, and with serverless IIIF just so very fast and for pennies essentially every month. So this is a really, really big win fundamentally. Um, and I think that we need to talk about the future. I think in the future that we need a out of the box approach for Hyrax and Haiku specifically that isn't kind of configured to be really slow. Um, and there's some permission stuff that needs to get worked out there. There's some, I think, concepts around how we store files. There are also updates for IIIF that are needed for Valkyrie support. So right now, the way Valkyrie stores files is different than the way Fedora 4 stored files. Whether you're using the Fedora 6 Valkyrie adapter or a Postgres Valkyrie adapter, you're getting them stored differently now. So like, there's some adaptation that needs to be done for that. But we need to come up with a solution that works out of the box, that works in dev, that works in production, that is deployable and simple. And I don't have a strong opinion here. which is not something that those who know me hear me say very often. I think that you could say, you know what, we're going to use Cantaloupe. A broad community uses Cantaloupe. It has all the features, and make that part of the stack the same way that Solar or Redis are part of the stack. I think that we could say, hey, Riff is the most Ruby-like way of doing it. We've had success with that in the past. We're going to do it by changing the way we configure Riff out of the box and make it the out of the box approach. And it scales with your Hyrax application. Like, that's a reasonable approach. Or we could say, hey, we're all in on serverless IIIF. We just need to expand its deploy options to allow for a like local version to run in Docker and to make it easier to deploy in Azure and GCP. And then we'll call that a day. All of those are viable options. But I think a decision by the community needs to be made so that we have a clear path forward and that we don't continue to ship it. A lot of people's first impression of the UV is that that stuff's really slow and not worth the accessibility trade-offs and the customizability trade-offs that you get from using IIIF. So I want to see IIIF continue to be a major component of the Samvera framework, and I think we just need to ship a better version of it day one so that people get an initial good impression. I often say that once you hate something, it's hard to ever love it again. And I think that we have done that with IIIF for a large portion of the community, where folks are just like anti-IIIF because the performance was bad. And so it's going to take time and momentum to kind of overcome that. And I think that the fundamentals of it just being misconfigured out of the box is something that we got to fix first before we can try and push that out. Questions and discussion.